Welcome back to another video, everyone. In today's video, I will be showing you how to create your very own object detection APIs that can be used to run detections within a web or mobile app. We will be creating two APIs that both take photos as inputs. The first will return a JSON with the dedicated objects detected, and it takes only milliseconds to make these requests. You'll be able to integrate these lightning-fast APIs into any application you wish. The second API is another post request, and it takes in an image as well, but this time it actually returns a string-encoded image that has the detections overlaid on top, so you would be able to return this in your web or mobile app. Once again, it is lightning fast. Let's get right into the video and create some APIs. So first things first, we need the code to follow along with this tutorial. So you can get the repository at my GitHub. So the AI guy's code and the repository is Object Detection API. I'll leave a link in the description below to the repository as well, so you can go ahead and get the code there. So first things first, we're going to go to the clone or download button and just copy over the URL and then open up a command prompt or shell. And then we're just going to do the classic get clone, paste our link in there and go ahead and click enter. So that's going to go ahead and download all the code for us that we need. And then if you look in the repository with the README, I've actually gone through and done my best to document the steps as well written out here. So if you're lost at any point throughout this video, just maybe pause the video and you can catch up in the README. You should be able to follow along with that as well. So that's a good resource. So we're going to now just cd into the repository, Object Detection API. And now we're just going to go ahead and open this in a code editor. I use VS Code. So the shortcut is code dot. That's going to go ahead and open it up. And you're going to go and see that you have all the files, which is perfect. So we're just going to close that for now and go back to our command line. So there's actually a couple of ways you can go ahead and install the requirements for this tutorial. You can use Conda if you have Conda activated. This is a super easy way. So if you have CPU and you don't have GPU, you just run these first two lines. And then if you do have a GPU and you want TensorFlow-gpu, you'll run the bottom two lines. I'm just going to show you the good old classic way, which is just using pip install. And for the sakes of the video, I'm going to do the non-GPU version, but the GPU version works just as well. So we're going to go back here and we are going to go to pip install -r requirements.txt. This is going to go ahead and just download all the dependencies required for this tutorial. So we're going to go ahead and let that finish, and then we'll come back. So once you have the pip install finished and all your dependencies are downloaded, the next step is we want to go ahead and get the pre-trained object detection weights that we are going to use for our API endpoints. So if you've seen my previous video on object detection using TensorFlow, you might be familiar with this. We're going to use the YOLO version 3 object detection weights for this tutorial. And this video actually kind of builds off of that previous video I have, so I recommend go checking it out. I've actually optimized the code a lot more, and you can actually use it, as you will see, with tiny YOLO. So if you're trying to implement these endpoints maybe for a mobile device, you can use those. But if you're just following along and you want the full capacity of the object detector, we're going to go ahead and get the standard weights. So if you're on Linux, you can go ahead and run this command in the command shell. I'm Windows, so I'm just going to go and click right here. And you're going to see that that's going to go ahead and download the weights for me. If you want to use custom trained weights, that is also an option, and this allows you to do that. I have a video on how to train a custom YOLO version 3 object detector. So if you want to train and make your own weights for your own classes, I'd go ahead and recommend watching this previous video. It's really good. But yeah, we're gonna just go ahead and we take the normal weights. So we're gonna go to downloads. So when you're in your downloads folder, you'll just grab this weight. So press Control-C to copy it. And then you're going to go back to wherever you cloned the repository. So I just cloned it in my C drive, repos, object detection API. And then you want to go ahead to the weights file, weights folder, and just Control-V and copy the weights in there. So now you have the YOLO version 3 object detector weights. And now it comes the time to convert those weights into an actual TensorFlow model. So checkpoint files and TF files. So we're going to go ahead and do that. And then we'll use that TensorFlow model for our endpoints. So yeah, so it's just an easy one-liner. So you just do Python load weights.py, and we're going to run that. If you're doing for the tiny YOLO, you're going to want to add these command line arguments. There's a flag for tiny. So if you're doing tiny, just run this command, but we're doing the normal YOLO. So once again, we're just going to do the default. All the arguments are defaulted for this version. So all we have to do, Python load weights.py and run it. And that's going to generate those TensorFlow model files for us. And then after that, we're going to be able to run our Flask app and use the APIs. So if we go back to the code, app.py is what runs our Flask app with the APIs exposed. So if you see in here, we initialize and load the weights in and the classes, and then we start our Flask app. And there's two APIs that you can use in this tutorial. We have one, they're both post APIs. This one is routed to /detections, so it'll be at our local host /detections. I'll show you guys an example in a second. And then, so what this does is it takes in image or images, and it actually will run the model on them, and it returns a JSON response that'll actually show you go through the images and show the classes that were detected and the confidence scores as an API response. So you could see how you could easily integrate that into a web app or a mobile app and just hit that endpoint with an image and then get the detections within your application to use as you wish freely. So that's pretty cool. And then we can see here our second API is routed to /image. It's also a post. And what this one does is it does the standard takes in an image and it returns the image as the response, string encoded as the response with the detections overlaid. So you could see how you would just hit this endpoint and show inside your application the detected image with the classes drawn on. And I'll show you guys an example of these, but it's really that simple. It's just these two endpoints. One returns a JSON with the classes that are detected, and the other returns the actual image itself with the detections laid on. So we go back and it looks like our weights saved, and we successfully converted our YOLO version 3 weights into a TensorFlow model. So you can see all the layers and stuff that it goes through, and all the params. But if we go now and take a look in this weights folder, before we only had our YOLO v3.weights, and now we have the required checkpoint and TF files for the TensorFlow model. So it successfully built our TensorFlow model from the YOLO v3.weights. So now that we have the weights successfully converted into our TensorFlow model, we can now actually go ahead and run our Flask app and use our APIs. So really, if you want to customize and you're using your custom weights or classes, you're going to want to edit a couple of things within the app.py at the very top of it, right here, and point to your TensorFlow model that may be named differently, as well as this is the pre-trained classes that get loaded in. So you'll have to change that if you're using your custom. You can also change in, if we go to code and YOLO version 3 tf2 models.py. There's actually a couple more parameters here you can tune. So right now, when we run our detections, we are limiting it to 100 classes detected within an image. So if you have an image of 300 cars somehow, it would only detect the top 100. And then we also have this YOLO IOU threshold. What this does is it changes the way, so if two images of the same class overlap a certain amount, when does it detect that they are separate classes, or does it detect them as one single class? So you can play around with that, but the standard is just to leave it at 0.5. And the score threshold here is the last parameter you can tune, and it's actually the confidence. So we will only, if it's at 0.5, only detections that run through the model and have a confidence score of over 50% confident that it's that certain class will be shown or detected. So if you did that up to 0.9, your model would have to be over 90% confident that a car is a car or a dog is a dog in order to actually return them and show those detections. So these are a couple parameters you can play around with, but I leave them as the standard 0.5 and 0.5. So to go ahead and now run our Flask app, you're just going to go and do Python app.py and go ahead and run that. And it's going to run the Flask app on port 5000 of your local host, your local machine. But if you wanted, you could easily sync this to run on a web app of yours, or like I said, a mobile app, and have those endpoints accessible within your actual applications. For the sake of this tutorial, I just did it on localhost so that everyone could easily get it up and running. So you can see that we're successfully running on localhost, which is also 0000, and at port 5000. So I'm going to use a software called Postman, which is great for testing APIs. So I'm going to go ahead and open my Postman. Let's go ahead and open that. And yeah, so if you don't have Postman, I highly recommend this way to test the APIs. You can also run curl commands, which I will show as well for the sake of everyone being able to do it. So I already have pre-populated my two APIs. So there's the detections API and the image API. The detections is the JSON response. So you'll just go ahead and create a post to your local host, port 5000 detections. And here's the key. So you go to body, you click on form data, and you have to type in the key as images. And then you have to select the file, or this file. It'll be as text by default, and you just change it to file. And then this will allow you to select files from your machine. So I'm just going to go to select and then C drive, where I put my repository, so repos, object detection API. And the repository comes with a couple of images pre-downloaded. So you're just going to go to data, images, and there's 3 images here that you can test. And you can actually press Control-C and do multiple photos. So I'll do these first 2, dog and meme, and I just go open, and it has 2 files selected, and you just go send. And you're going to see that after it only takes 2.5 seconds, you get the response. So if I just scroll down, we can see that the response comes back with the detections. This is JSON format, and it detects dog with a confidence of 99%, bicycle with a confidence of 99%, and truck with 93.4. And if we actually go ahead and open our image, we can see that that is exactly what's in the image itself. One thing to notice, if you're not familiar with YOLO version 3 and the weights that we use, the pre-trained weights, there's 80 classes or so within that model that it can predict. So if you just go and Google Coco dataset classes, it'll show you a list so you know what images out of the box you can run this model on. Otherwise, you might want to have to do the custom detector, like I said, and train custom weights to do classes for a specific use case that you might want to run your application, whether it's a web app or mobile app, towards. So that's one thing to keep in mind. So yeah, so it runs. You see we have the first 3 detections with our, and it shows that these are within the image that was uploaded called dog.jpg. So it actually tells you what image it was found in. And then the second image, the meme, if we go to it, we see that it has a bunch of stuff within the image, and it actually detects all of those that are within the data set, the Cocoa labeled data set. So we got cup, person, laptop, apple, chair, and cell phone. And when we check apple, cell phone, laptop, cup, clock, person, and chair. So it actually goes ahead and gets almost everything within this image and is able to get the class and the confidence all with high accuracy. So this could be a really useful API within a web application where you want to find something within so you could decide whether it's person in a picture and actually from this API display person found, no person, stuff like that. So it's a cool API, really useful. And now I'll show you guys the second one that comes when you run the Flask app, which is image API. So the body, form data, images, file type, it's all the same key. And we go ahead and go to, our repo, object detection API, data, and images, and we'll go ahead and do the dog. So this is the API that will return the image encoded in string format with the labels over top. So you can see that takes milliseconds, only like a second, and it returns the image with the classes on it. This API only will take 1 image at a time, just because I'm not sure how to return multiple images string encoded. So that is one limitation of this one. But you can see how easily within a web application or mobile app, you would be able to just upload a photo and have it show on the screen the detections made within. So that might be a future video that I do, showing you guys these APIs used in a sample application. If you guys think that would be useful, let me know in the comments down below and I'll go ahead and do that. But you can see how these APIs response times are super fast. So 2 images detected and returned in 2.5 seconds. And the image itself returned within 1.4 seconds. So both are extremely fast. And if we actually go back to the README itself, it'll show you guys how to do this. And now I'll go ahead and show you an alternate method to access these APIs. So you can actually, if you open up another command prompt or shell, because you have to leave the one open running, and I'm just going to go to the repository. And now I'm going to copy this curl command. You might have to install curl if you don't already have it. And I'm just going to go ahead and run that with the uploading the dog image. And you can see that within the command prompt, it goes ahead and returns the detections. So it's using the same API, just another way of accessing it. I'm going to also test out the office.jpg because I haven't shown you guys that one. And it can find a couple of chairs, people, and TV monitors within the image. So that's really cool. And I just quickly will show you the second API through a curl command as well. So we'll go ahead and run the image API. Go ahead and run that. And yep, looks like it worked. To verify this one, because you can't return and open up a image within the command prompt, like a string encoded image, I have it outputting to test.png. So if we go into our code, we can see that we have a new file here called test.png, and it's successfully returning that image with the labels over top. So everything looks to be working. So that's pretty much it for this video. It's showing you how you guys can easily, with only a couple commands, set up either this out-of-the-box 80 classes object detector using TensorFlow and Flask, and have two APIs, one that returns the image with the classes detected with the bounding boxes on top, and another that actually returns the JSON response, which could be used in a vast amount of use cases. So two really cool APIs that are really quick and fast. Yeah, so that's that. And then if you watched one of my previous videos, the TensorFlow object detection, this kind of allows you from this repo to do the exact same stuff. So you can just do detections just using the TensorFlow model itself and not using APIs. So the APIs are great for, like I said, the web or mobile app. If you're just playing around with detections on your local machine, you can go ahead and run a bunch of various commands. You can do detections on a webcam right here by running this, video files, and then actually save videos with the detections overlaid as the video plays. So similar to one of my past video, but this one allows a lot more customization and can actually be used with Tiny YOLO. So that's great if you're using Tiny YOLO. Yeah, but other than that, and it shows you all the arguments you can use to modify these. So if you're just looking for another TensorFlow model out of the box, this is another great repository that has a bunch of more, it's a lot more configurable than my last video and uses Fluent TensorFlow 2.0, whereas one of my previous videos kind of had a couple tf.compat.v1, so still used a couple of version 1 uses of the TensorFlow APIs. So this one's purely TensorFlow 2.0, and it's a lot more configurable. That's the thing to get across. So if you're looking for another TensorFlow model, you can run these with this repository. But I hope you guys enjoyed the video. If you did, smash the like button on this video. It means a lot to my channel. And subscribe if you haven't subscribed, and you'll see a lot more videos of artificial intelligence and object detection as well. So thanks a lot, guys.